Alright guys, we're going to be looking at systems of equations, specifically systems of linear equations. Three of them. Okay, the first one says use substitution to determine if 0, 2 is an element of the solution for the system of equations. So let's go ahead and use substitution. Here we go. Let's see here. So this is x and this is y. So here's what I'm going to do. Okay. Notice that this is a skeleton for this first equation. This is a skeleton for the second equation. So I'll just plug in 0 and 2. 0 and 2. And now I could do both at the same time, but I'll just continue here with this one so it doesn't get so distracting. So here we have 0 plus 6. So we have 6 equals 6, which is true, okay, but we're not done. This solution should work for both to be a solution to the system. So now I'll plug in 0 for x. I'll put in 2 for y. Here we have negative 0 plus 2, which is just 2, equals 8. That's not true. So therefore this is not a solution. Okay. Okay. So we have, okay, don't let this be confusing. Bottom line, 0, 2 does not work as a solution. Okay, 0, 2 is not an element of the solution set. But notice that for you to operate with this, it's either a yes or a no. I guess we can keep it simple. Okay, so it's either a yes or no. Yes is a solution. No, it's not a solution. In this case, it's a no. So we'll keep it simple. Why? Because it's got to check out this equation should be true and this one should be true as well. Alright, use a graph to solve the system. Okay, you'll be looking at a problem like this. What you want to do is solve for y. Okay, although it's one system, okay, it's got two equations and you want to solve each one for y. So let's take the first one. I'm going to go ahead and add 5x to both sides. Okay, I'm actually not writing the steps here, so it's not as distracting, but you can. And next I'm going to divide by 4, as we all know to do here. Okay, so we have 6 over 4 plus 5 over 4x. And I'll put it in y equals mx plus b form, so we have 5/4 x plus, we'll reduce this to 3/2. Okay. Next, I'm going to continue with this other equation. Solve for y. I'm going to go and subtract 3x to both sides. I'm going to divide by negative 1. And I'll finish off with y equals mx plus b form. Okay, so 3 over 1 x minus 2. Alright, so it says use a graph. So I'm going to now take advantage of the calculator. I'm going to punch those in. So here we go. We got 5/4 x plus 3/2. x plus 3/2. I'll hit enter. Okay, there he is. I'm going to hit tab so I can enter the second equation or function. And it reads 3 over 1x minus 2. Three over 1 x minus 2. Let me double check that. Okay, I'll hit enter. Alright. Use the graph to solve. Okay, so to solve, the solution is, people, the intersection So there's different methods. Here's one using our technology. We'll hit menu, come here to graph, and number 4 is intersection. Okay, here's asking me for a lower bound, so I'll hit it, place it on this side. Now it's asking for an upper bound, and as you can see, it's giving me 2, 4. Okay, let me see if I can pinch that. In case you can see it, so 2, 4 would be that intersection or the solution here. So let's go back. So 2, 4 is our solution. Okay, let's go move on. This next one, classify the system and determine the number of solutions. So this is very similar to the one we just did. Okay, so we definitely are going to want to solve for y, so let's go ahead and get that taken care of. One system, right? This symbol here, this brace, tells you, hey, you got one system that has 2 equations. So here we go. Okay, quickly here we would add 7x. And again, I'm not writing those steps, I'm speaking them only, so it's a little less writing for you guys. But if you need to do it, here I'm going to divide by -6. So I'm going to switch these two, so I have -7 over 6x, and I'm going to have plus 4 over -6, which is 2 over 3 negative. And I know a lot of you guys like using the minus sign there, so let's do that. Okay, let's move on to the next one. So although it looks like a lot of work, as long as you know what you're doing, it's a smooth sailing here. Okay, so here's this next one. -24y equals 16. Here we're going to go ahead and add the 28x. So it can cancel there. 28x equals 16. Notice what I did here, I put it here in the front so I don't have to move it later. Now I'm going to divide by -24. So y equals, I shouldn't go that fast, let me see here. There's a 28 divided by the -24x plus 16 over the -24. Let's go and simplify. So this is -7 over 6x plus -2/3. So I'll go and erase that again. So we keep the same kind of flow. Okay, so now that I have these two, okay, notice it does say classify, which is a little extra. We'll talk about that in a second. Determine the number of solutions. So let's go ahead and do what we did on the last problem and just kind of graph it on the calculator. So -76x. -7, 6. Okay, x. Where are we? -2/3. Minus. Okay, and I'm putting them in parentheses just because of conversations we had in the past. I'll hit enter. And I'm going to hit tab, get that second one in, which is -76x. Minus, oops, -7, 6 x -2/3. Could have put that in parentheses. Let's do it. Okay. Now, if you notice, right, this line and this line produce the exact same line. Okay, that's not a mistake. This is to illustrate the following. Okay, so as far as the graph goes, that's done. Now they do want the solution, so we got to talk about that. Solution or solutions. So let me give you this bit of information. Okay. Now this might come to you a little fast, but you can pause the video and write it down. Here is something very important when it comes to classifying these linear systems. Whenever you have two lines intersect at one point, you've got one solution. Okay, exactly one solution. Then you have a case like this where you have an original line and then the second line happens to be identical. Okay, so they're overlapping each other. There you'll have infinitely many solutions. And then you have this special case, okay, where, in case you didn't know already, they have the same slope but different y-intercepts, so therefore these would never intersect, so there'd be no solution. Okay, there's a lot of good stuff here that you can jot down. Now in terms of classifying, okay, ours is this one, so it is consistent, and here's the definition you can jot down, okay, for your notebooks. And it's also dependent, also here for your notes. Okay, and they're saying that the graphs are coinciding lines. They have the same slopes and the same y-intercepts. So if we come back this way, we can say that it is consistent, and we'll add the word dependent. Okay. Consistent. So sorry, the solutions was infinite. So we'll put that on here. Infinite. And as far as classification, it's consistent. Consistent. As you'll read when you jot those notes down, there's a solution, and it's dependent because it's virtually the same line. Okay. Now the last thing I'll say as we wrap it up here is that the reason there's infinite solutions is if this point works on that first line, since it's overlapping, it'll work on the second. So will that point and that point and that point. Which is different than this one, right, where they only meet at one point, so one solution. And this one, if it works for this line, that point will never work here because they never intersect. So hopefully that helps. Okay, see you guys tomorrow.